Hello everyone, welcome to today's class. This is Teacher Simon taking you through Pure Mathematics 1. This is paper 9709/11 for May-June 2025, and this is part 2 from question 7. Now question 7, they're saying the equation of the curve is this one here, and they're saying part A, a point P is moving along the curve in such a way that its y-coordinate is decreasing at 5 units per second. Find the rate at which the x-coordinate of the point is changing when x is equal to 2. Okay, so what we are given is dy dt, which is a -5 because they said it is decreasing. So if they say it is decreasing, you put a negative. If it is increasing, then you put what? A plus. Okay, now our y is equal to 4x squared, then plus 9x to the power of -2, then minus 8. We need to get dy dx because we see changing in the x and the changing in the y. This will be 8x, then minus 18, then x to the power of -3. Okay, when you differentiate a constant, that one goes. Now, at this point here, for x is equal to 2, what will be the dy dx? So dy dx here is going to be 8 times 2, then minus 18 over 2 cubed. Okay, what does this one give us? 8 times 2, then minus 18 out of 2 cubed. 2 cubed is 8. So that is 55 over 4. 55 over 4. Okay, now we need the rate at which x coordinate is changing. So that is dx dt, which is actually equal to dx dy, then times dy dt. Because this one can cancel with this, then you remain with your dx dt. So we do this under chain rule. Okay, using chain rule. Now dx dt, dx dy is 1 over dy dx. So we shall have 1 out of dy dx. This is the value, which is 55 over 4. And then times dy dt is -5. So meaning we are going to have this one here will be 4 over 55, then times -5. This one will go here 11 times, and that means our answer is going to be -4 out of 11. As simple as that. Part B, find the coordinates of the stationary points of the curve and determine their nature. We know that for stationary points, then dy dx is equal to what? 0. What is our dy dx? It is here. So it is 8x, then minus 18 over x cubed, which is equal to what? To 0. Now I'm going to multiply all through by x cubed to eliminate this denominator. So this will be 8x power 4, then minus 18, which is equal to 0. And then our x is going to be the 4th root of, when you take this one here, it is going to be a positive, then we can divide by 8. See that? But since this one is an even power, then we have plus or minus. You see that? So I'm going to have plus or minus, then the 4th root of this one simplified by 2, 9, then by 2, 4. Okay, so that will be that. But also this one is the same as saying this is 9 over 4 power half, and then again power what? A half, because this can multiply with this. You see that? You know that this power a quarter, this one here, the 4th root, is written as 9 over 4, then to the power of what? A quarter. So the square root of this one is going to be a 3 over 2. Not so. Just like that. So for this case, we can have root of 3 over root of 2, which is the same as saying root of 3 times root of 2, then over root of 2 times root of 2, such that here it's like I've done nothing, but we are removing the third in the denominator, and this one becomes a what? Root of 6, then over 2, plus or minus that. You see? All right. Now, having gotten that, they want the coordinates. So we shall say for x, which is equal to square root of 6 over 2, what will be y? Y here is 4x squared. 4x squared plus 9 over x squared, which is root of 6 over 2, minus 8. What does this one give us? And then also for the negative, and remember they said find the coordinates of the stationary point C. So it is not 1. So when you don't put plus or minus, you are going to get only 1 point. So this will be a minus. I'll put a minus here, and we'll say minus here. So what do we get altogether? 4 into, we have square root of 6, and then we divide by 2 here, then we square that, then plus 9 out of, then we have the square root of 6 out of 2, and then we also square that, then minus 8. This one gives us a 4. Then for this other one, I'll just come here, put a minus. Wherever there is root 6 over 2, I will just put a minus. It is also what? A 4. Actually, they were squares. So the square of a negative and a positive, they give the same answer. So meaning the stationary points are, we have root 6 over 2 and 4, then negative root 6 over 2 and 4. Remember, you can also write maybe this one here, no problem. You can also write this one here, root 3, or you can even write it as root 3 over 2, just like that, or root of 1.5, whichever you want. That is good for you. So that is that. Then they said, hence, determine their nature. So to determine the nature, we need to differentiate the second time. So the second derivative here is going to be, remember our dy dx. What is our dy dx? Dy dx is equal to 8x minus 18, then x to the power of negative 3. So here we shall get 8, and then this will be 54, then x power negative 4. So that will be that there. So 4x, which is equal to positive root 6 over 2, what will be the second derivative? What will be the value? Would it be positive or negative? So 54, then out of, this is the square root of 6 over 2, then power 4. Now, this one is going to give us, of course, this one will give us a positive. Even when it is a negative, this one will also come out as a positive. 8 plus 54 out of, then we have root of 6 then out of 2, and then I power that with a 4. So we have 32. This 32 here is less than, the 32 here is greater than what? 0. So because it is greater than 0, then this is a what? A minimum point. Okay. We shall also say for, because it is going to give us the same thing, for x which is equal to negative root 6 over 2. So I'll put here, I get the same thing. Then we shall say both are minimum, both are minimum points. That is their nature. Question 8 is coming from circles. The circle with this equation here intersects the line x is equal to negative 2 at points P and Q. Find the area of the triangle formed by the tangents at the circle, tangent to the circle at P and Q, and the line x is equal to negative 2. Now I'll begin by finding the coordinates of P and Q. Okay. Then from there I find the equations of tangents at P and Q. Then from there, these two tangents will meet, okay, at a certain point. So we need to find a point of intersection of these two equations. Okay. Now this one will give us, for example, the height here of this triangle, and this is x minus is equal to negative 2. That means we can be in position to find the area of that triangle. Okay, let's start. Now for x which is equal to negative 2, we substitute here. So negative 2 squared, then plus y squared minus 6 times negative 2, then plus 10 times negative 2, then minus 27. This one will be equal to what? To 0. So we shall have y. No. I made a mistake here. This one is supposed to be 10y. Pardon me here. 10y. Okay. And then from here, we are going to get a quadratic in y squared plus 10y. Then this one is a 4 plus 12, that is a 16. 16 minus 27. Isn't that negative 11? Yes, negative 11, which is equal to 0. Two numbers, when I multiply them, they give me negative 11, but when I add them, they give me 10. I think we shall have 11 and 1, but 1 has to be a negative. So we have y plus 11, and then y minus 1, which is equal to 0. So meaning y is equal to negative 11, and also y is equal to 1. So I can take my p to be negative 2, negative 11, and then my q to be negative 2, and then 1. So these are the coordinates of the points of what? Intersection. Okay. Now, to find the equations of the tangents, let's say we have this one here, and we also have that one there. Maybe this is point Q, this is point P. We have a property in circles that the angle between the radius and the tangent is 90 degrees. So we need to find the center. Since we know these coordinates, we know the coordinates of P, and then we need to get the coordinates of the center such that we can get the M1, and then using M1 times M2, which is equal to negative 1, we shall be in position to get M2, and that is the gradient of the tangent. And remember, to be in position to get the equation of a tangent or a straight line, you need to get at least one point through which a line passes and its gradient. You see that? So let us complete squares for this one here to find the center. Okay, I'm going to write x squared minus 6x, then plus y squared plus 10y, maybe 27 goes this side. Divide this one by 2, you get a negative 3 squared. Then pop it out as a square, and then y, divide this one by 2, you get a 5. Put it in brackets in the square, and then you pop it out as a square, and is equal to 27. So we shall have x minus 3, and then y plus 5. No. This one is squared, then plus y plus 5 squared, and then this one is equal to, this is 27, okay, plus 9 plus 25. 27 plus 9 plus 25, that is 61. So we get 61 here. So therefore, the center of the circle is 3, negative what? 5. Because remember, the general equation of the circle is x minus a squared, then plus y minus b squared, which is equal to r squared. That means if we wanted to get the radius, it will be root of 61, right? And then here the center is AB. So you just change the signs of these ones, okay? So from there, now I can actually do a small sketch here. And let's say we have our circle. This is the circle. Now, after getting this circle here, the center is 3, negative 5. Let us locate where P is. Negative 2 has to be on the left. And then negative 11. So it has to be like down. Negative 2. In fact, that is the line x is equal to negative what? X is equal to negative 2. Okay. That is x is equal to negative 2. So this is point P, which is negative 2, then negative 11. And then Q has to be this one, which is negative 2, 1. You see that? Now, we need to get a tangent like that. A tangent at Q. And then we also have a tangent at P. Let's say it is that one there. Just do it like this. Yes, like that. These two are going to meet here. You see that? So they want us to find the area. You want us to find the area of that triangle formed. So the area of this one here between the two tangents. So this is tangent at Q. Actually, it is P. Then this is tangent at Q. Now you can see that these two are meeting, okay? So we have to find the equation of tangent at Q. Equation of tangent at Q. Now remember, I told you that the tangent and the radius are always, are always perpendicular. So that is 90, 90. Now, M1 here is going to be equal to, change in y, negative 5. So I'm using these two coordinates, okay? Negative 5, then minus 1 out of 3 minus 2. This one will be negative 6 divided by what? 5. You see? Now, M2 is going to be equal to negative 1 out of this negative 6 over 5. This one is going to be equal to 5 over 6. This is gradient of tangent of tangent at Q. Okay, remember M1 times M2 is equal to -1 for perpendicular lines. Now we have y minus y1, which is equal to m into x minus what? x1. So y minus our y1 is this. We are using a point through which a line passes. So this is 5/6. And then this is x minus -2. So what do we get here? Y shall be equal to 5/6 of x. And this one is a positive. So we shall have 5/3 because the 2 reduces the 6. Are we there? And then plus 1, meaning you have y, which is equal to 5/6 of x. And then plus, this will be 3 plus 8. Plus 5, that will be 8/3. I keep this one here. Okay. Then after that, there is something you need to know. For two tangents, let me write here NB. For two intersecting tangents to the circle, if one tangent has a gradient of m, then the gradient of the other is -m. This one is very, very important. Therefore, gradient of tangent at P is equal to, the gradient here we got this 5/6. Then for this one it is going to be -5/6. You can prove that you can do the same thing here. You get the m1, use these two, then after you use m2 is equal to that, you'll get the same value, this one here. So in the exam, when you just deduce like this, it is okay because it is known. Okay, now after doing this, we need to find now the equation of tangent at P. Okay, equation of tangent at P. We have y minus y1. Our y1 is -11. Then is equal to m, which is -5/6. Then into x minus x1 is -2. So meaning y, first of all, this one is a plus. Then when it crosses, it is going to become a minus. So we have -5/6 of x. And then here you have a +2, which reduces this one to a 3. And we have -5/3. Then remember, this one is a plus. So when it crosses, it's a minus, right? So -11. So meaning this y is going to be -5/6. 3 times -11, you get -35. -33. Then -5. That is minus what? -38/3. This is the equation of the tangent at Q. Now we are supposed to solve these two simultaneously. Solving the two equations simultaneously, we shall have 5x/6 plus 8 over 3. Then this one is equal to negative 5 over 6 of x minus 38 over 3. So bring this one here. So I have 5x over 6, then plus 5x over 6, which is equal to negative 38 over 3, and also negative 8 over 3. Now what do we get here? This one is like saying 5 over 6 of x, then times 2, which is going to be 5 over 3 of x. Not so? So 5 over 3 of x then is going to be equal to 38 plus 8. That one will give us 46. Not so? So it will be negative 46 over 3. So when you cancel these 3 here, our x is therefore going to be equal to negative 46 over 5. Now, that means where they are meeting here, it's negative 46 over 5. That is from the what? That x coordinate is going to be from the y-axis. You get it? So when I come back to this one here, our y-axis is going to be here. Let me say, I draw that one there as my y-axis. This is y-axis. You see that? Where is x-axis going to be? X-axis, already this one is above, then this one is below the x-axis. Probably the x-axis is going to be here. This is the x-axis. Okay. Now, from this is 0. So from here, the y-axis to here, we are having negative 46 over 5. Okay. Negative 46 over 5. Now, the height of this triangle is going to be this one here, then minus this smaller one here. You see that? Okay. So area of triangle, you know, it is equal to a half times the base, then times the perpendicular height. So we shall have a half times, now the base, we shall come to this, and it is going to be the difference between this one and the negative 11. Okay, that is the vertical. It is a change in the y. So we shall have 1, then minus 11. You see that? Then times the height. Our height is going to be here. It is here. So it is going to be, remember, from the y-axis here to this point here, it is going to be negative 46 over 2. But there is a minus 2 here, okay? Because this x is equal to negative 2. So we are going to get a difference between these two, okay? And then that one will give us this one, which remains. You get it? So this whole thing, then we subtract off this negative 2. So that means I will have minus 2, then minus 46 over 5. It doesn't matter whether you do this first, then you subtract off this negative 2, but the whole thing has to be a what? A positive, because length cannot be a negative. We are taking this one here as a height. Do you get that? Okay, which is a length. So meaning here we shall get, of course, this will be 12. So you have a half times 12, then times, so this one is a plus, even this one here will be a plus. Now 5 times negative 2, that will be a negative 10. Then plus 46, that will be a positive 36 over 5. So, all right, there is the positive. So we have 6 times 36 over 5. And then our final answer becomes 6 times 36 out of 5. We get 43.2. As simple as that. Question 9 is coming from circular measure. The diagram shows a sector ABC of a circle with center A and radius r centimeters. The angle BSC is alpha radians, where alpha ranges from 0 to pi over 2. Part 8 is given that the area of the triangle ABC is 4 centimeters squared and the area of the sector ABC is 8 alpha centimeters squared. Find the exact area of the shaded segment. Now we are given area of a triangle ABC, which is equal to what? 4. An area of a triangle which is not right angled, we just need to have this side known, and the angle in between. Okay, so meaning we are going to have a half times r, then sine of the angle in between the two lengths. Okay, then this one is equal to 4. Not so. Now that means when I can make maybe r squared over to the subject of the formula, this one can be equal to 4 out of sine of alpha. Not so. There is also something they said, area of the sector. Area of sector is always equal to a half, then r squared, then the angle. That is if it is in radians. So area of a sector is given as 8 alpha, which is equal to a half r squared alpha. So do you see how alpha is going to go? And then a half r squared is equal to 8. That means this one here, if it is 8, then I can just substitute it here. So that means 4 over sine alpha then shall be equal to what? 8. When you cross multiply, then sine alpha shall be equal to 4 over 8, which is a half. So meaning alpha shall be equal to the arcsine of a half, which is going to be 30 degrees, or pi over 6. Then from there, they want us to find the shaded area of the shaded segment. So I will say shaded area then will be equal to, which one is bigger? The sector, and then the triangle is smaller. So area of the sector minus area of the triangle. So area of that segment is going to be equal to area of sector minus area of triangle. Now the sector is ABC, the triangle is also ABC. Area of the sector, what is area of the sector? Was given as 8 alpha. Are we there? So we shall have 8 then times our alpha, which is pi over what? 6, minus area of the triangle, which is actually 4. It was given as a 4 here. So simplified by 2, 4, then by 2, 3. I can just leave my answer there, just like that. Centimeters what? Squared. If you want, you can put, no. Actually, they said exact area. So don't put your answer to 3 significant what? Figures. Part B, it is given instead that the length of the chord BC is r over root of 2 centimeters, but the area of the triangle ABC is still 4 centimeters squared. Find the area of the shaded segment. Give your answer correct to 3 significant figures. Okay, now when we check here, BC, we know this, and then they are asking for the length of this one here. That means we can use cosine rule. So I can say using cosine rule, we have BC here shall be equal to the square root of r squared, then plus r squared minus 2 times r, that is r squared, then cos of the angle that is opposite to BC, which is alpha. You get it? And actually this one is given as r over root of 2 here. All right, now we can square both sides even. So this is 2r squared, then minus 2r squared cosine of alpha, and this one here shall be equal to r over root of 2. Now from here, square both sides. When we do so, we shall have 2r squared minus 2r squared cos alpha, which is equal to r squared over 2. You see that? Now r squared is common. That means it goes away. So we shall have 2 minus 2 cos alpha, which is equal to what? A half. You get that? Now we have 2 minus a half is equal to 2 cos alpha. And then this one will be 4 minus 1, that is 3 over 4. I mean 3 over 2. Then when we divide by 2, it will be 3 over 4. So cos alpha is equal to 3 out of 4, meaning alpha will be equal to the arc cos of 3 out of what? 4. I can keep that. Then from there, what else do we have? Remember, area of the shaded segment, I will need a half times r, then sine alpha. So what will be sine alpha? This is cos alpha. You can use this triangle here. Okay, right angle triangle. And then we say if this is alpha, cos is adjacent over hypotenuse. That means this one here is going to be 4 squared minus 3 squared. Not so? And what does it give us? Root 16 minus 9, isn't that a 7? So we have root of 7. So meaning sine alpha is going to be equal to 1, opposite over hypotenuse. So root of 7 over 4. Or you can say, after getting the value of cos alpha, we know that sine squared alpha plus cos squared alpha is equal to 1. So that means sine alpha will be equal to the square root of 1 minus cos squared alpha, not so? So we shall have the square root of 1 minus, this is 3 over 4, then squared. Let's check it out. Square root of 1 minus, that will be a 9 over 16. So you get root of 7 over 4. Root of 7 over 4. Just like here, you see that? Shaded area of segment, you know, we said is equal to area of sector minus area of triangle. So area of the sector is going to be a half r squared alpha, then minus area of the triangle, they said is still 4. Not so. They must have said so. It is still what? The 4. Now, we substitute here. We can have a half times our r squared. R squared. We have r. So we need to find r. Okay. So let me take this one down, maybe there. Now, area of the triangle, you know it is equal to a half, then r squared sine what? Alpha. But it is equal to 4. So that means, remember we need r squared. So r squared shall be equal to, when we cross multiply, that will be 8 over sine what? Alpha. So r squared is going to be 8 over sine alpha. We have gotten it as this, root of 7 over 4. So I can write this as, let this one go up. That will be 32. So 32 then over root of what? 7. Then I will come to this one here and I say r squared is 32 out of root of 7, then times alpha. Okay, so what is alpha? It can either be the arc sine of this or the arc cos of 3 over 4. So let me write the arc cos of 3 over 4, then minus 4. And to three significant figures, what do we get? Remember here, the calculator has to be in radians. Mine here is in degrees, so I will have to change it to radians. Now we have 0.5 times 32. This 32 is out of root of 7. Then from there, we have the arc cos of 3 out of 4. Then minus 4. The answer becomes 371. 0.371 centimeters squared to three significant figures. That is that. Question 10 is coming from functions. The functions f and g are defined by whatever is here. And they are saying part A, describe fully a sequence of transformations which transforms the graph of y is equal to f of x to the graph of y is equal to g of x. You should make clear the order in which the transformations are applied. Now, let's say my y, okay, my y1, my y is equal to root of x, that is the f of x here. Then after the first transformation, let's say, since here there is a 3, I can say 3, then times this. And this is a stretch in a stretch by factor 3 parallel to y-axis. You see that? Then next, I can see something added on the x here. So my y2 can be 3, then root of, then x plus 2. Now here, since we have added an x, when it is coming out, it comes out as a negative. So this is a translation by vector. We have 0. No, it's on the x. So we have minus 2, 0. You change the sign. It's a plus here. Then in the vector, it comes out as a negative. I've always explained this in all the papers that I've done on this channel. So you can peruse through those questions of transformations. You'll get it. And then, because we have, if you have y is equal to f of x plus a, then we have a translation by vector negative a, 0. You see that? Okay. Now, let's proceed. What are we going to have here? The next one is now going to be what we have gotten here, then we are subtracting a 5. This is a translation by vector. Something has been done. This is the y coordinate already, so we are subtracting a 5. Something is being done on the y, so 0, then negative 5. Okay, so those are the ones we are having. Alternatively, we can have these two, okay, put together into one. You get it? These two will give me a translation by vector -2, -5. So you can write this one here in the place of these two. So you have this as the first one, then this as the second one. You get it? So that is that. It was very simple. Then here they are saying the diagram shows the graph of y is equal to g of x. On the diagram sketch, the graph of y is equal to the g inverse of x together with any relevant Miller line. Remember when we are finding the equation of the inverse, we interchange x and y. That means since we are interchanging x and y, what was x becomes the y, and what was y becomes the x. Automatically, we are going to have x here. I mean, a reflection in the line. Okay, we are going to have a reflection of this graph in the line y is equal to what? X. So when they say that the relevant Miller line, this is the one. Okay, and actually better you make it dotted. The Miller lines, we always show them with dotted lines. They are supposed to be dotted lines. Okay, now we just reflect this one here, something like that. Okay, part C, find an expression for the inverse of g. When I come back here and I check what is given here, let g inverse of x be equal to y. That means if I take this g this other side, then x will be equal to g of y. That is interchanging x and y. So our x here is going to be equal to, what is g of y? G of y is 3 and root of x plus 2. But where there is x, I will put a y. Then there is a minus what? 5. Now we make y the subject. So bring this one here. We shall have x then plus 5, which is equal to 3. The square root of y plus 2. Divide all through by 3. X plus 5 over 3 is equal to the square root of y plus 2. Square both sides. You shall have this one here over 3 squared. Then will be equal to this one squared. It disappears. And then your y is going to be equal to x plus 5 over 3 squared minus 2. Therefore, the inverse of g is going to be x plus 5 over 3 squared minus 2. If you want, you can simplify that, but they never told us to put it in the simplified form. Then state the range of g inverse. Now, if I have x here and then g acts on it, okay, then what comes out is the g of x. So this is the domain of g, okay, and what comes out is the range of g. Are we there? Now what undoes what g did is the inverse. Are we there? But you know that what we put in the function is the domain. So the values here are in the domain of g. Then what we get out is the range. Now also here, since we are putting values in this g inverse, that means this set of values here is now the domain of the g inverse, and this becomes the range. You see that? So meaning this one here is going to be the domain of g inverse, and this one here is going to be the range of g inverse. You see that? So meaning right from here that the range, they want the range of this. The range of g inverse is equal to the domain of g. But range is given in terms of what? The function. So this is the domain of g. X greater or equal to negative what? 2. Now, I'll go back here and then I write that x which is greater or equal to negative 2, but it has to be written in terms of the g inverse. So I don't write this. When you write this, you're wrong. You write g inverse of this one. then will be greater or equal to negative 2. Then here they are saying the function h is defined by h of x is equal to x minus 2 for x greater or equal to 0. And they are saying find the value of the g inverse of h of 4. So I need to first get h of 4, which will be 4 minus 2, and that is a 2. That means g inverse of g inverse then h of 4. We are composing this h of 4 into the g inverse. This one is the same as saying g inverse, then you put the h of 4, not so? And here, the h of 4, we have gotten a what? A 2. Now g inverse is here, so we just substitute, not so? So this one will be equal to 2 plus 5 over 3. We square that, we subtract 2. What will be the answer? We have 2 plus 5, that is a 7. 7 squared, that is a 49. Then 3 squared, that is a 9. So 49 over 9, then minus 2. And that one is 31 over 9. 31 over 9. And that is our answer here. Simple as that. Part F, explain why the composite function h g inverse cannot be formed. Now, here, let me also take you through this. We are going to have x here, okay? And then g inverse goes through it. And then here we are going to get g inverse of x. Now, when we have hg inverse, that means you are composing g inverse into the h. That means now h will act on the result here, okay? H will act here, and then what comes out is our h, then g inverse of x, okay? So the whole root here is h g inverse. You see that? Now remember, what is put in the function is its domain. This is the domain of the g inverse. What comes out is the range of the g inverse. This range of the g inverse must be fitting in the domain of h. You get it? Because if h acts on the g inverse, that means this one will be falling into the domain, because what you put in the function is the domain. You see that? Now, let me write my statement here. For hg inverse to be formed, okay, the range of g inverse, okay, must fit into the domain, of h. Now let's look at range of g. Range of actually g inverse, okay? Range of g inverse. What do we have? We have even just written it here, I think. G, it is g inverse of x greater or equal to negative 2. Then domain of h, it is here, x greater or equal to what? To 0. Only positive values. You have a number line here, 0, and then the rest. That is where h is starting from. Then the values of x that go into h from 0, then onwards. But then for this one here, it has negative 2 here. So that means when you get this to fit it in here, it can't. It's like when you are covering yourself with a very small, let's say, blanket. You see, you cover yourself up to the knees here, then the legs remain out. You see, so that means you cannot be composed into that what? Blanket. I don't know whether it makes sense. So I will say Hg inverse, okay, is impossible, because, and by the way here, remember we are putting x values into the function. So if we say G inverse is greater or equal to -2, we can transform this into x greater or equal to -2. You get it? Such that these values then do what? Go into the H. They are just values. All right. Now, G inverse is impossible because, Hg inverse is impossible because the range of G inverse, okay, is not within the domain of H. So this becomes my answer. Just this. I've used these ones here to show you how it comes about. So that has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.